Good day, students. Today we will be considering what we call vectors in physics. Okay, my name is John Ogodo. So in this class we'll be looking at the concept of resultant of vectors. We'll also be looking at vectors, resolution and application, and how we can add vectors together algebraically using parallelogram law of vectors. So in this class we'll also look at multiple forces or multiple vectors acting at a point and their resultants. We'll look at the analytical method, and we'll also mention the graphical method of determining the resultant of two or more vectors. Okay, as we go on, we have to remind ourselves of what a vector is quickly. We say that a vector is a quantity that have magnitude and direction. A quantity that have magnitude and direction. In previous class we said the examples of vectors are force. We have force. We have momentum. We have moment. We have force field. We have displacement, and so on and so forth. Then we also have the other one which we call the scalar quantity. A scalar quantity is a quantity that have only magnitude but no direction. Examples of scalars are speed. We have speed. We have distance, mass, length, volume, area, and so on and so forth. So these are examples of vectors and scalars. So moving on to what we call the parallelogram law of vectors. We say that the parallelogram law of vectors states that when two vectors or forces are represented by the adjacent sides of a parallelogram, the resultant force is a single force which is drawn along their common point in magnitude and direction. Okay? We can have it there on the slide. You say when two vectors are represented by the adjacent side of a parallelogram, the resultant vector is a vector drawn along their common point in magnitude and direction. So we can consider this diagram and how to determine the resultant using parallelogram law of vectors. Now let's consider two vectors, A and B, or P and Q, as shown. We have vector P and vector Q, and they are acting at angle theta between each other. How do we find their resultant? To find their resultant, we draw a common point vector R, which is known as the resultant. Okay, so we can do this to complete the diagram to make it look as if it's a parallelogram. So here, if theta is here, that means here will also be theta, and this angle here, based on your angle measurement, will be 180 minus theta. So with that, you can solve the resultant by using or by applying cosine rule. Remind yourself of, let's remind ourselves of cosine rule. Let's consider a triangle ABC with opposite side here A, opposite side here C, opposite side here B. Remember that A squared equal to B squared plus C squared minus 2BC cos A. So if we have this as the law or extension of what we call the cosine rule, we can apply it here considering this triangle. Let's say O, R, and this point. So if you consider that, we have R squared equal to P squared plus Q squared minus 2PQ cos 180 minus theta. So theta is the angle between the vectors or the forces P and Q. So let's assume that P is equal to 2 newtons and Q equal to 3 newtons. And we want to find it. The theta between them is 30 degrees. We can solve for the resultant using the formula stated. So we have R squared equal to P squared, which is 2 squared plus 3 squared minus 2 multiply 2 multiply 3 cos 180 minus 30. So 2 squared is 4. 3 squared is 9. Minus 2 times 2 is 4. 4 multiplied 3 is 12. Multiply cos 150. Cos 150. So 4 plus 9 is 13, minus 12, multiply cos 150 is cos 30 in the negative quadrant. So cos 30 is 0.866 with negative sign because cos 150 is in the negative quadrant. So we cannot subtract this, we have to multiply before doing any subtraction. So multiply 12 by 0 point that and find the square root of the answer obtained, and you find out that your vector or resultant can be determined from there. Okay, so looking at the other aspect of application of this resultant vector using the parallelogram law of vectors, we can also find the angle that the resultant makes with any of the forces, either P force or Q force. How do you find the angle it makes? We find the angle it makes by also looking at the diagram once again and saying here is P and here is Q, and we have theta, and the resultant is here R. So we can look for the angle. Let's see how we can look for the angle. Okay, that is diagram drawn completely. We have here theta, here 180 minus theta. Okay, so we're looking for this angle. Let's call this alpha. So for us to solve this, we need to apply sine rule. So since we're able to solve the R squared, or R equal to square root of P squared plus Q squared minus 2PQ cos 180 minus theta. So you can solve for your R using the parallelogram law of vectors. Then to find alpha, we use sine rule. Use sine rule. And if you apply sine rule, here is P and here is Q. Here is still our R. So therefore, R divided by sine 180 minus theta is equal to P facing alpha. So you have P divided by sine alpha. So cross multiply R sine alpha equal to P sine 180 minus theta. So make R the subject. So divide both sides by R. Divide both sides by R. This cancel this. Sine alpha is equal to P sine in bracket 180 minus theta divided by R. So alpha is equal to this sine inverse. Sine inverse of P sine 180 degrees minus theta, all divided by R. So with this, you get the alpha, the angle the resultant makes with the horizontal force Q. You can also get it with the one it makes with the force acting here, which is P. And to get that, we say alpha, can call this beta or beta. So alpha plus beta equal to theta. So therefore, our beta angle will be theta minus alpha. So with this, you can find the angle it makes with the P force by subtracting this. That means your beta angle is equal to theta, which is what you have here, minus sine inverse in bracket P sine in bracket 180 minus theta, close bracket, divided by R. So we have this equation for finding the angle it makes with the P force or the component P. Or with the theta, we use this one, which is this normal one. So we can see some examples on that using the concept of parallelogram law of vector, applying an angle here. Let's say here is given as 120 degrees, and we have here as 3 newtons and here as 4 newtons, and we want to find alpha. So to find out alpha, we need to find the resultant. So what is the resultant? To find the resultant, we say R equal to P squared, that is square root. P squared, you have 3 squared plus 4 squared minus 2 multiply 3 multiply 4 multiply cos 120, that is 180 minus 120. This is 120. So we simplify or evaluate that, and that we have 9 added to 16. 2 multiply 3 is 6. 6 multiply 4 is 24. Cos you can say cos 120 minus 180 minus this is 60 degrees. So, and that will give us 9 plus this is equal to 25. 25 minus 24, cos 60 is 0.5. So we have square root 25 minus 24 multiply this is 12. 25 minus 12 is 13. So square root of 13. So you can get that using your calculator. So you have root 13 newtons as the answer to that. So with that, we can also solve for the angle alpha using the angle, what we say the formula, sine inverse in brackets P. The P force here is this force, which is 3. 3 sine 180 minus 120 divided by R. The R force here is root 13, so we have square root of 13. So when we simplify, we have sine inverse P force, which is 3 sine multiplied by sine 60 degrees divided by root 13. So when we do the multiplication, we have sine inverse in bracket 3 multiply sine this is I can say root 3 divided by 2 over root 13. We'll simplify this further. We have sine inverse 3 root 3 divided by 2 root 13. So you can solve this using your calculator. You get the value of alpha from the equation or from the expression we have there. So going by this, we can also look at the concept of resolution of vectors. When we look at the formula for resultant, we can use that formula, and we look at the triangle law of vectors. But before that, we want to consider the resolution of a vector. When we are given a vector, but before that, we look at a vector that is P force, and at an angle theta to the horizontal, we have the x and y axis. So the force acting here is the horizontal component, and the force acting here is the vertical component. So from here, using Graphical concepts, we can say that the P force, the relationship here, can draw this and form your angle 90. We have sine theta equal to opposite, which is Fy over hypotenuse, which is P. So therefore, Fy is equal to P sine theta. So we have this as the vertical component. That's the vertical component of the force. So here, we can also solve for cos. Cos theta is Fx divided by the P force. When we cross multiply, Fx is equal to P cos theta. So we have the horizontal components, horizontal and vertical components. So when we are able to establish this, then we can say that the components have been determined. Then you can recall, using Pythagoras theorem, we can solve this if this is angle 90 degrees. That means if we have here as Fx and have here as Fy, and this is your resultant P, we can use Pythagoras theorem, P squared equal to Fy squared plus Fx squared. Okay, so we can solve and say P equal to square root Fy plus Fx squared. And if you substitute, we still arrive at the same answer, showing that the answers are correct. So we are given this. We are given a force of 100 newtons at an angle of 45 degrees. And we are asked to look for two forces. Here, I call this one Q force, and here P force. So find P and Q. How do you find P and Q in this diagram? Relating this to these equations, we have P equal to the P force equal to F, or the force 100 sine theta, which is 45. So 100 sine theta. So we have 100 multiply sine 45 is 1 over root 2, which is same thing as 0.717. Okay, 0.717. So approximately, we have 71.7 newtons, approximately. So Q force, the same thing. We have 100 cos 45. 100 cos 45. So we have 100 multiply cos 45 degrees is the same 1 over root 2, which is 100 multiplied 0.717 approximately. We have 71.7 Newton. So that will give us similar, because the angle there is 45 degrees. So solving or going forward, we can find the resultant of more forces. We can apply the triangle of forces to solve some related problem in vectors. Okay, so let's see how we can solve related problems using triangle law of vectors or triangle law of forces. When we are considering three forces that are represented in magnitude and direction by the three sides of a triangle, taken one after the other. So we have a force. Let's call this one force P. I'll have this one force Q, and we have this force R. Okay, and the angles between them are stated. Let's say here is alpha, here is beta, and here is gamma. We have alpha, beta, and gamma angles. So that means using triangle law of forces, triangle laws of vectors or forces. That means we have P over sine gamma is equal to, we can take Q divided by sine alpha, and that is equal to R over sine beta. But recall that in your mathematics, sine alpha is equal to sine 180 minus alpha, provided that alpha is less than 180 degrees. So this holds. So that means this can change or be transformed to P divided by sine 180 minus gamma is equal to Q divided by sine 180 minus alpha is equal to R divided by sine 180 minus beta. So we have this. We can also call it Lami's theorem, but it's useful in solving problems where you have three forces given maybe with an angle, and you're asked to look for the other side. So you can solve a simple problem when we have three forces. We have this 5 newtons, we have this 10 newtons, and we have this unknown, and the angle given is here. Let's say the angle given is 60 degrees. So I'd like us to use the triangle of forces to find the resultant or the unknown using the triangle of forces. So going forward, we look at what we call a resultant of 3 or more forces. A more suitable situation, we'll call it Polygon of Forces. When you have polygonal forces, where you have 3 or more forces acting on a system or acting at a point, you say that the forces are polygonal forces or polygon of forces. Now, when we consider this case, we look at a situation where you have forces. Let's consider this. We have these forces. Let's say here is F1, F2, F3, F4 forces acting at angle 90 degrees to each other. Then we can find the resultant of the vertical component and the horizontal component. So the vertical resultant, let me call it vertical resultant. Vertical resultant is equal to Ry. So Ry is equal to F1 minus F3. Okay? And the horizontal resultant will be equal to Rx. And Rx is equal to F2 minus F4. So if you consider these two equations, then we can reduce the diagram to simple diagram of this nature, where here is Ry and here is Rx, Ry and Rx. Okay, so if you find the resultant using Pythagoras theorem, we say that R squared equal to Ry all squared plus Rx all squared. So R equal to square root Ry squared plus Rx squared. Okay, so that is for the resultant. And the angle phi which is this angle, the angle the resultant makes with the horizontal force, horizontal component, is given as tan of angle phi equal to this side, and this side is ry, that is opposite over adjacent, okay? Opposite over adjacent, so phi is equal to tan inverse of ry divided by rx. So this is the angle the force makes with the horizontal component. You can also get it with the vertical component by subtracting phi from 90 degrees. So we can solve a problem on this considering four forces acting at perpendicular directions to each other. We have here as 12 newtons, and here as 8 newtons, here as 6 newtons, and here as 3 newtons. Now I want to find the resultant of this and the direction with respect to the horizontal component. So if we find to find the resultant, let us get the Rx. And Rx will give us 6 minus 3, and that is 3 newtons. And Ry is equal to 12 minus 8, and that is 4 newtons. So drawing a diagram to represent the two, we have Rx, which is 3 newtons, and Ry, which is 4 newtons. So the resultant is R. R squared is equal to 4 squared plus 3 squared. R squared equal to 16 plus 9. 16 plus 9 is equal to 25. So R equal to square root of 25. Square root of 25 is 5. So we have 5 newtons. So that is the resultant force, the magnitude of the resultant force. The angle that the resultant makes with the 3 Newton component will now become tan inverse or tan phi equal to 4 divided by 3. So 4 divided by 3 is equal to 1.333. So we have angle phi equal to tan inverse 1.333, which is the angle you get. You can punch the calculator and get the answer to that. I will not give a big deal. So with that, you can also solve problems that are also related to this, where you have more forces that we need to resolve. Let's say we have 5 forces here with an angle added, or with a force added, which is, let's say here is 4 newtons, here is 5, we have 3 newtons, we have 2 newtons, and we have 2 Newton force. I want to find the resultants of the forces acting at point O. Let's say this point O. To find the resultants here, we need to look at the resultant horizontally and the resultant vertically. So what is the resultant horizontally? From here, we have these forces, 3 Newton and 2 Newton acting along the horizontal line. So we have 3 acting in the positive direction and 2 acting in the negative direction. That means you need to add them algebraically, considering their direction. So you have 3 minus 2. Then you add the 5 Newton for resolve with 30 degrees. So you have 5 cos 30 degrees. 5 cos 30. So 3 subtract 2, you have 1. Added to 5 cos 30 is 0.866. Or you can say 1 plus 5 root 3 all divided by 2. So we can say 1 plus 5 root 3 over 2. So you can get this as the Rx. This is the Rx force. Then we have the Ry. Ry force will now become 4 subtract 2. 4 subtract 2. Then we have this acting upward plus 5. This angle is 30 sine 30. 5 sine 30. So you have 4 subtract 2. You have 2 plus 5 multiplied by sine 30 is 0.5. So we have 2 plus 2.5. 2 plus 2.5 is 4.5. So this force here is 4.5 newtons. So with that, you can find the resultant by using this. Ry squared plus Rx squared. And the values of Rx is this, and the value of this is this. So we can substitute and get it. Using the other angle, so we can find the angle of the force or the resultant with respect to the horizontal. So Ry over Rx. So I want to leave this for you to solve, so you can apply what you have done and solve that. And lastly, Lastly, we need to consider a condition where the forces are not represented, but you have to represent the forces on the diagram. Okay? If you want to represent the forces on the diagram, you need to consider how the angles are stated. Let me say, from your basic knowledge of trigonometry or bearing representation, if you are given a force, consider a force F represented as 2 newtons at an angle of 30 degrees. Let's say 030 degrees. To draw this, we consider this diagram. We're using this point as a reference point. This point that is along this. If I consider the what we call the map or the directions, we can call this the north pole, south, east, and west. Okay, that is the 4 cardinal points. So if we consider the 4 cardinal points, we can use the east as the reference point. So to draw this F 2 newtons 030 degrees direction, we measure from here 30 degrees and draw this. So these are 2 Newton force. This is the force acting at 2 newtons. If you also have force of 100 newtons acting at angle 150 degrees, you do the same thing. We have the reference from here again. We have 90 up to here. 90 plus 90 plus what will give us that? That will give us 40. So we have this angle 150. So 150, that is 60. So this force is 100 newtons. 100 newtons. Here will give us 60 degrees, and here is 90. That means 60 plus 90 is equal to 150. So with that, you can represent forces using the what we call the graphical concept. And with that, if you apply that, you can find the resultant of 2 or more forces with respect to the diagram that have been drawn, considering the length or the magnitude of the force or the vector that is given. So let's look at an example on that, looking at find the resultant. Find the resultant of the following vectors. So we have F1 as we have 8 newtons at an angle of 120 degrees. We have F2 as 10 newtons at an angle of 150 degrees. And we have F3 as 12 newtons at an angle of 90 degrees. Okay? I can call it 090 degrees. 090 degrees. Okay? So how do we solve that when we are asked to solve? So to solve that, we need to apply the value that has been given. So let me draw the diagram so that we see what we are trying to represent there. So we have this. F1, 8 newtons, 120 degrees. 8 newtons, 120. Measure from here. 120 will give us 90 plus 30. So it's acting at this angle. So this is F1 force, 8 Newton force, 8 newtons. The next one is the angle here. You need to represent the angle here, which is 30. Here will be 30 degrees. The next one is force F2. F2, 10 newtons at 150. So you measure again 150. So that will be around here. So take it from here. That is 10 newtons force at 150. So you call this F2. The next one is F3, which is acting at angle 90 degrees. Angle 90. So that means it's acting here. Angle 90. This is angle 90 degrees. So that is 12 newtons. So you can find the resultant of this by resolving them based on that. So you'll do the same thing. Get your Rx. Rx here will now be with respect to the angles given. So you need to find the corresponding angle here and here. For example, the angle here, this is 150. Added to this, that will be here will be 30. So here, in this case, here is 30. So here will be 60. So the total angle is 60. So that means if you are solving, what you are going to have is our Rx is now acting in the negative direction. In the negative direction. So we have minus 10 cos 30. Okay, minus 10 cos 30, which is the F1, that is the F2 force. Then the next one is 8. So we have minus again 8. Minus 8 cos 60 degrees. So this will give us the two forces that act the resultant along the horizontal direction. And RY is equal to this force, which is 12 acting positively, and resolve this 8 newtons. So we have 8. You need to resolve it vertically this time around. So you have 60 here. 8 sine 60 degrees. Then with the 10 newtons force, we have 10, this 30, this 60. So we have 10 sine 30. So with this, you get your resultant using the same formula stated earlier, RS squared, RY squared. So you can solve them and get the direction as well. Phi equal to tan inverse RY divided by RX. Okay? So I would like to leave you with this question to solve. I'll leave you with this question to solve. Just two questions. We have one of them. Find the resultant of these forces. We have this. We have 100 newtons force. Here is 50 newtons force. Here is 30 newtons force. And here is 10 newtons force at angle 90. Then the second one is this. We are given this. Here is 20 newtons force, 10 newtons force, 8 newtons force, 15 newton force at an angle. There's another force acting there, which is 18 newtons at angle 45 degrees. So find the resultant. Then the last one is find the resultant of these three forces. F1, 100 newtons acting at angle 045 degrees. Then F2, 200 newtons acting at angle 270 degrees. Then F3 is 50 newtons. 50 newtons acting at angle 300 degrees. Okay, find the resultant of each of them and their direction. So with that, we have come to the end of this class. I believe that you have learned a lot in this elaborate class. We wish you, as you continue to watch the videos, you'll be able to learn a lot of things in physics. Okay, so thank you for listening.